Imagine there is a quiet, swirling paradox in the night sky, a truth so simple it takes the entire history of human civilization to accept it. We do not know what we are seeing. The stars, the dust, the luminous silk of the Milky Way, they are all ancient texts written in a language we are only now starting to truly learn. And in the year 2020, a small, dark traveler appeared, whispering a new, confounding word into the deep silence. We thought we knew what a comet looked like. A comet is a dirty snowball, a cosmic iceberg, and when it approaches the sun, it begins to breathe. Its volatile ices, frozen water, carbon dioxide, methane, sublime, turning directly from solid to gas. This forms the beautiful, ephemeral coma, that ghostly, expanding halo of light, and the signature tail, sometimes stretching millions of kilometers behind the nucleus. This is the simple, elegant poetry of the solar system, a predictable choreography of heat and ice. When astronomers first spotted object 3I Atlas, its trajectory marked it immediately as an interstellar visitor, only the second ever detected passing through our local neighborhood. But the data, gathered over weeks by observatories across the planet, began to form an impossibility stack. It was speeding through space, carrying with it a distinctively non-Keplerian velocity, meaning it was not born here. It was a visitor from beyond the solar system's grand attic. Yet, as it drew closer to the warming light of our sun, it stubbornly refused to develop the expected signature coma, and it possessed no discernible tail. The finest telescopes, calibrated to detect the faintest exhalations of gas or dust, found nothing but a sharp, point-like object, an unresolved dot of light. It looked less like a comet and more like an asteroid, an inert chunk of rock. But what if the very absence of that signature, the refusal to perform the expected icy dance, was in fact the most profound signature of all? What if it wasn't simply a rock? And what if it wasn't merely a dead comet? What if this silent, dark object, labeled 3I Atlas, was something engineered? A massive, cold object, moving under the influence of gravitational mechanics, but somehow protected from the cosmic heat and radiation, a kind of hermetically sealed vessel. The great silence of space seems endless. Yet what if it is merely interrupted by these quiet, dark ships, passing us by, unseen, unannounced, unconcerned? This is the core question that began to trouble the minds of the quiet researchers, the philosophers of the distant light. It echoes a very ancient, universal anxiety. Are we truly alone, or are we simply too loud to hear the whispers of the universe? Close your eyes. Let your breath slow. The air in the room feels still, perhaps cool against your skin. Imagine standing on a ridge, overlooking a vast, dark desert, looking up at that silent, point-like wanderer. It travels without a sound, without a trail, carrying secrets that span light years. Leave a comment telling me what time it is and where you are listening from tonight. We are about to begin a long, slow journey into the evidence. We do not know what 3I Atlas truly is, but the newest image looks nothing like a comet, and the implications ripple far beyond the edges of our imagination. We may already be part of the experiment. Imagine a vast, perfectly black ocean, and in that ocean, you are sailing on a small, brightly lit ship. The ship is our solar system, and all the objects we know, the 8 planets, the billions of comets in the Oort cloud, are familiar passengers. Object 3, I Atlas, is not a passenger. It is a silent traveler, a ship passing in the night, coming from an unknown port of call and heading towards a distant, unknown destination. Its detection was an act of serendipity woven into the fabric of tireless, routine observation. You see, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is how the object gets its name, is designed to spot things that might one day collide with Earth. But on the 28th of December, 2019, the telescope in Hawaii found something that was not going to hit us, but was instead going to leave us, moving along a hyperbolic trajectory, meaning its path was an open curve, dictated by the combined gravity of the Sun and the planets, but ensuring it would never be captured. The initial designation was simple, a comet, but the deeper the data went, the more the conventional narrative began to erode, like soft sandstone in a slow, persistent wind. The core evidence for a comet is the presence of that coma, the atmosphere created by the sublimation of ice. This is crucial. If an object is a dirty snowball and it crosses the frost line, that invisible boundary in the solar system, where the sun's heat begins to actively vaporize the surface ice, it must start to shed material. 3I Atlas crossed this line, moving well within the orbit of Mars, yet remained spectroscopically silent. The light reflected from it was not surrounded by the spectral signatures of water vapor, hydroxyl radicals, or the cyanogen gas that characterize a comet's breath. This was the first anomaly, the refusal to breathe. The second anomaly was its shape, or rather, the complete lack of resolution. Even the largest telescopes on Earth, with their adaptive optics correcting for the shimmer of our atmosphere, could only render it as a perfect point source. This suggests an object that is either extremely small, perhaps only a few hundred meters across, or one that is extremely dense and non-reflective, perhaps possessing an unusual geometry that minimizes its visible cross-section. Now, a typical comet nucleus is lumpy, often shaped like a peanut or a potato, and it rotates, causing slight variations in brightness that tell us about its size and spin rate. 3I Atlas presented no such readily decipherable light curve, only a faint, unwavering speck, moving with an unnerving, almost mechanical precision against the backdrop of the stars. The third and most subtle anomaly lies in its acceleration. Astronomers, using the equations developed by Sir Isaac Newton centuries ago, can predict the path of a space object with astonishing accuracy. But sometimes, objects defy simple gravity. Comets, for example, often exhibit non-gravitational acceleration. As the ice sublimates, jets of gas blast off the surface, acting like tiny, continuous thrusters, subtly pushing the nucleus off its predicted path. Comet 3I Atlas showed a very slight, but statistically significant, non-gravitational push. But this is the paradox: a push without the visible gas. The traditional explanation, the jetting ice, is invalidated by the first anomaly, the complete absence of a coma. So, we are left with a subtle, non-gravitational force, but no visible engine. The spectre of ice is a kind of cosmic fingerprint. Everything we see in the solar system carries the mark of its birth and its history. The dry, heat-baked inner planets, the ice-rich outer worlds. But 3I Atlas seems to have erased its own fingerprints. Consider the ancient mythic link to this idea of a traveler who passes through undetected. In many cultures, there are stories of the wanderer, the stranger who appears briefly, observes, and then departs, leaving behind only quiet confusion. The object, in its perfect silence and unheralded passage, has become a contemporary version of that myth, a visitor from the eternal beyond that refuses to speak our local language of ice and dust. This refusal to conform forces us to adopt a cosmic perspective. If this object came from another star system, from one of the perhaps hundreds of billions of stars in our galaxy, it has likely traveled for millions, if not billions, of years. It has been exposed to the full spectrum of the galactic environment, cosmic rays, tiny but powerful dust impacts, and the crushing cold of the interstellar medium, which is only 3 degrees above absolute zero, a temperature of -270.15 degrees Celsius. For the object to survive such a journey and then not react to the warmth of our sun in a conventional manner suggests a fundamental difference in its composition, or, perhaps more intriguingly, a form of protection. The very surface of the object must be incredibly robust, capable of weathering the long, cold war of space without flaking, cracking, or sublimating. This is a level of durability that natural, brittle cometary ice rarely exhibits. We are beginning to see a theme emerging, an echo in the deep quiet. The object is acting as if it is not supposed to be there, or perhaps acting as if it is not supposed to be seen. The non-gravitational force without visible outgassing, the point-like image without a coma, the interstellar origin without a classic cometary composition. All these threads weave a tapestry of profound and beautiful mystery. The simple label of interstellar comet is wearing thin, failing to contain the complexity of the observations. And yet, even then, we were just observing the motion. We had not yet begun to look at the chemical composition of the object, which would introduce an entirely new layer of strangeness. To understand this world, we must go further back, to the moment when the first unexpected spectroscopic reading was taken, painting a picture that was less snowy and more strangely metallic. The transition from visual mystery to chemical paradox began with the slow, meticulous process of spectroscopy. You may think of light as a simple, continuous beam, but to an astronomer, light is an orchestra, a symphony of color and energy. When sunlight reflects off an object in space, the material composition of that object leaves its fingerprint on the reflected light. Elements absorb and re-emit light at very specific, signature wavelengths, creating a unique barcode that reveals the object's chemical makeup. This is how we know, for instance, that the Sun is made mostly of hydrogen and helium, and that distant comets are rich in water ice and organic molecules. When the light from 3I Atlas was captured and separated by powerful instruments attached to telescopes like the Very Large Telescope in Chile, the data initially seemed thin. No robust, signature lines of gas, no evidence of the typical cometary breath. But one faint, persistent spectral line began to appear, a signature that should not have been present in a natural cometary nucleus, the absorption line for iron. Iron is the bedrock of terrestrial planets, a heavy element forged in the heart of dying stars. While iron dust exists in comets, the specific, persistent signature was more indicative of a metallic composition than the expected fluffy, icy aggregate. The object's visible spectrum was surprisingly reddened, meaning it was scattering more red light than blue light, a common trait for space objects that have been heavily irradiated, but also a potential indicator of unusual surface material. We must pause here to grasp the cosmic significance of this observation. A comet, by definition, is a pristine relic of the early solar system, a kind of time capsule that has remained essentially unchanged since the formation of the planets, roughly 4.5 billion years ago. These relics are rich in volatiles, the low boiling point ices. An object like 3I Atlas, arriving from another star, should carry the equivalent chemical fingerprint of its own primordial planetary system. If it is a comet from another star, it should be made predominantly of the same kind of spacefaring snow and dirt. But the reddened spectrum and the possible iron signature hinted at a composition that was far more akin to a dense asteroid, or, even more dramatically, a kind of processed material. This led to the quiet but intense re-evaluation of its classification. If it is a natural asteroid, why is it moving on an interstellar path? To be ejected from its home star system, an asteroid would need an exceptionally powerful gravitational slingshot, perhaps from passing too close to a gas giant or the system's primary star. Such a violent ejection would imply a very dynamic, perhaps unstable, planetary system of origin. And yet, if the object is primarily metallic, why the non-gravitational acceleration, that subtle, unpowered push? These two key pieces of evidence, the metallic fingerprint and the unexplained motion, seem to cancel out the two most conventional explanations, comet or asteroid, leaving only a new, unsettling third option. The astronomer who perhaps first articulated this third possibility with a quiet, scholarly conviction was Dr. Avi Loeb from Harvard University. Dr. Loeb is a figure of gentle controversy, known for his rigorous science blended with a philosophical openness to the unexpected. His core argument, published in an array of scientific papers, centered on the idea that when all natural explanations are ruled out, we must be open to the possibility of an artificial origin. He suggests that the unique properties of 3I Atlas, the small size, the point-like appearance, the lack of a cometary tail, and the non-gravitational motion without visible outgassing could be consistently explained if the object were a piece of extraterrestrial technology, a fragment of a light sail, or a discarded piece of equipment from an advanced civilization. This is where the humorous humility of science shines through. We spend billions of dollars on telescopes and computational power, all to be stumped by a small, dark rock that refuses to melt. The universe, it seems, has a subtle, dry wit. We search for grand, sweeping signals, for huge alien megastructures, and instead, the possibility of life beyond Earth is whispered to us by a tiny, enigmatic object that merely refuses to sublime. It is an understated anomaly, a piece of cosmic debris that doesn't follow the rules of our local celestial mechanics. The shift in perspective is profound. We move from studying the thermodynamics of ice to contemplating the engineering of civilizations. The iron signature, if confirmed, takes on a new meaning. Iron, a strong, malleable metal, is essential for large-scale construction. A natural iron-rich asteroid would be unlikely to be ejected with such a clean trajectory, but a structure built for interstellar travel would be designed for maximum durability and resistance to the harsh galactic environment. The air feels sharp and dry as you consider the timescale. This object has survived a journey that might have started when Earth was still ruled by dinosaurs. The chemical fingerprint, therefore, might not be one of creation, but one of purposeful preservation. The cosmic perspective forces a deep reflection on our own technological history. We are, ourselves, beginning to experiment with solar sails, thin, mirror-like membranes designed to capture the faint pressure of sunlight to achieve massive velocities without propellant. Could the non-gravitational acceleration of 3I Atlas be the result of a similar, perhaps damaged, sail that is catching a subtle, continuous push from the sun's photons? The slight, continuous nature of the non-gravitational force supports this idea. as it's a push that is more consistent than the sporadic bursts of a typical cometary jet. We are looking at an object that might be using the light of our star to accelerate away from us, efficiently and silently. We are now gazing not at a speck of primordial ice, but potentially at a faint, metallic reflection of our own distant, technological future. And yet, even in this heightened state of speculation, we have overlooked a crucial piece of the puzzle: the nature of the object's spin, or lack thereof, which holds the next key to the mystery. The next step in the quiet investigation moved from composition to dynamics, specifically the way 3I Atlas moved through space, not just along its orbital path, but how it rotated on its own axis. Everything in the universe that is not perfectly spherical and that exists in a gravity well will tumble. Planets wobble slightly, asteroids spin haphazardly, and cometary nuclei often rotate chaotically, a result of billions of years of random collisions and the uneven forces of outgassing. The study of an object's rotation, or its spin state, is a subtle but powerful way to determine its history and its physical form. For weeks, the global network of observers attempted to pin down a reliable rotation period for 3I Atlas. They were looking for the familiar periodic variations in brightness that signal an irregularly shaped object turning in the sunlight. Imagine a long, slender piece of wood spinning in the light. Its brightness would flash as the broad side and the narrow side alternately face you. The data from 3I Atlas, however, remained stubbornly flat. Its brightness simply did not change in the expected periodic way. This led to the third set of anomalies: the unwobbling artifact. First, the most straightforward explanation: the object is perfectly spherical. In a natural context, a perfect sphere is almost impossible to maintain for a small, interstellar object. Impacts, weathering, and gravitational tides would inevitably introduce irregularities. Second, the object is rotating very, very slowly, perhaps a period of hundreds of hours, making the spin difficult to detect in the short observation window. But the third, more intriguing possibility links directly back to the idea of artificiality. The object possesses a low reflectivity, matte surface that absorbs most of the sunlight, effectively minimizing the variation in reflected light regardless of its orientation. A matte, dark surface would be ideal for surviving the harsh radiation and heat of the inner solar system without excessive thermal stress, or indeed, for simply avoiding detection. Dr. Avi Loeb, observing this lack of spin, offered a compelling thought experiment. He asked us to imagine a flat, wide object, like a pancake or a cigar shapes, that maximize the ratio of surface area to mass, which is precisely what one would design for a solar sail or a light-driven propulsion system. Such an object would naturally be more stable and less prone to tumbling if it were moving under the gentle but continuous pressure of sunlight. A natural object, especially one that is small and moving so fast, should tumble wildly. The fact that it does not suggests a degree of rotational stability that is highly unusual for a naturally formed interstellar piece of debris. This uncharacteristic stability connects the three anomalies we have discussed: the lack of a coma, the metallic fingerprint, and the low spin rate. A naturally tumbling comet would expose different sections of its volatile ice to the sun in an uneven way, which would cause an uneven distribution of outgassing, leading to a visible coma and chaotic non-gravitational forces. A flat, structurally sound, non-spinning object, however, could be moving with a subtle, non-gravitational acceleration, precisely because its surface area is perfectly aligned to the photons of the sun, acting as a photonic collector. The object is not breathing ice, it is sailing on light. The scientific evidence deepens the mystery, suggesting a structural coherence and a purpose that transcends simple celestial mechanics. Let us consider the mythic link here. The object is behaving like a talisman, an artifact of such perfect construction that it exists outside the common laws of decay and chaos. It is the story of the perfectly balanced shield, the silent sword that never rusts. In the deep time of the cosmos, where everything erodes and dissolves, an object that maintains a perfect, unwavering trajectory and an unperturbed rotational state is a kind of cosmic impossibility unless it is designed that way. We are asked to accept that nature has randomly created a tiny, silent, dark object, shaped in a way that maximizes its efficiency for interstellar travel while simultaneously minimizing its visibility. This requires a statistical leap that many scientists find uncomfortable. The human reflection on this quiet, unwobbling artifact is perhaps the most profound part of the story. You are sitting here, listening, and your own planet is spinning at 1,000 miles per hour, or about 1,600 kilometers per hour, carrying you along a vast, complex orbit. We are all on a spinning sphere, an irregular, lumpy, beautiful, and volatile world. The thought of a small, cold, silent object passing by that is more stable than our entire planetary home is a profound source of calm tension. It is the peace found in cosmic scale. We are loud, bright, and constantly moving. This object is silent, dark, and perfectly balanced. The search for a confirmed rotational period continues to this day, with telescopes around the world dedicating precious minutes of observation time to this single, faint speck. If a reliable, short spin period were found, it would largely return the object to the realm of the natural, a dense, dark asteroid, perhaps. But the longer the observations remain inconclusive, the more the case for a purposeful stability strengthens. The lack of an answer becomes an answer in itself. The refusal to reveal a rotation is the object's quiet form of resistance, and this resistance, this perfect silence in the face of our intense curiosity, is what drives us to look beyond simple rocks and ice. To truly grasp the implications of this perfect silence, we must look backward, to the echo of the past, to a time when other anomalies challenged our view of the cosmos. To truly understand the quiet revolution initiated by 3I Atlas, we must look back to the moment of its predecessor's discovery, the object known as Oumuamua. In the Hawaiian language, Oumuamua means a scout or a messenger from afar, and when it was discovered in October 2017, it was a singular moment in the history of astronomy, the first confirmed object from outside our solar system. The discovery was immediately exhilarating, providing the first tangible evidence that the galaxy is filled with objects traveling between stars. Oumuamua immediately presented a suite of challenges that paved the intellectual road for the later speculation about 3I Atlas. The object was initially classified as a comet, then quickly reclassified as an asteroid, and then, most famously, it defied both categories. Visually, it was highly elongated, potentially shaped like a cosmic cigar or a pancake, perhaps 10 times longer than it was wide. This strange, elongated geometry was the first major anomaly. Astronomers have never observed a natural asteroid or comet with such an extreme shape. Imagine the chance collision and sculpting events required to naturally form a rock of that proportion. It is not impossible, but it is statistically unlikely. The second anomaly, and the most crucial link to 3I Atlas, was Oumuamua's non-gravitational acceleration. Like its successor, it was speeding up as it departed the inner solar system, an acceleration that could not be explained by the simple pull of the sun's gravity. For a comet, this is routine. The sublimation of ice creates the thrust, but Oumuamua exhibited no visible coma, no detectable spectral signature of the gas jets. The telescopes found nothing, only a bare, dry object being mysteriously pushed. Where 3I Atlas showed a slight push, Oumuamua showed a more pronounced, undeniable one. The scientific community struggled to explain this push without the presence of the gas jets. One major theory proposed was that the object was venting a gas we could not see, perhaps pure, frozen, molecular hydrogen or nitrogen ice. These materials are extremely cold and would sublime far from the sun. But more importantly, their signature is very difficult to detect with conventional ground-based telescopes. The venting of this unseen ice could provide the mysterious thrust. However, this theory required the object to be made of these very exotic, super-cold ices, which would have to survive a journey of millions of years through interstellar space and then suddenly begin jetting precisely as it passed our sun. This is where the humorous humility of the scientific method resurfaced. We are confronted with the vast complexity of the cosmos, and we are forced to choose between two improbable scenarios: a cosmic iceberg made of rare, undetectable gas that survives an epic voyage, or an object that is non-natural. Dr. Avi Loeb, once again, stepped forward to propose that Oumuamua's properties, the bizarre elongation, the lack of coma, and the unexplained acceleration, were best explained if it were a light sail, a thin, broad piece of equipment, perhaps derelict, designed to travel using the pressure of starlight. The geometry of a light sail is elongated or pancake-like. A light sail would possess non-gravitational acceleration without visible outgassing, and a thin, manufactured structure would minimize its vulnerability to impact. The cosmic perspective offered by these two travelers, Oumuamua and 3I Atlas, is staggering. We realize that the galaxy is not only filled with stars, but it is also filled with interstellar debris. Hundreds of billions of stars means countless objects, fragments, and perhaps vessels are passing through the solar system every few months, mostly too small and too fast to detect. The two objects we did manage to spot both possess extreme anomalies, the three anomalies now forming a quiet, consistent pattern: unusual acceleration, no visible coma, and unconventional shape or density. It is the cosmic equivalent of opening two drawers in a huge house and finding that both contain an identical, complex, and unidentifiable tool. The emotional arc here is one of peaceful realization. The possibility of life beyond Earth has always been a grand, loud concept, reserved for science fiction and large radio telescopes. But Oumuamua and 3I Atlas offer a quieter, more subtle narrative. The great cosmic wave is washing pieces of its complex, long-dead, or long-forgotten technological shore onto our small, gravitational beach. We are not hearing a shouted message. We are finding beachcombing artifacts, scraps of a vast, ongoing cosmic enterprise that is indifferent to our presence. Imagine the sheer scale of the journey these objects have undertaken. They have surfed the gravitational waves of the galaxy, enduring the millennia. They are the quietest of echoes from the past, reminding us that other suns have planets, and other planets have histories. The memory of Oumuamua gives us the framework for interpreting 3I Atlas, not as a unique oddity, but as the second data point in a potential new class of objects, interstellar wanderers that defy our basic understanding of cometary physics. We are not just observing two stray rocks. We are beginning to catalogue what could be a galactic shipping lane, one that we never knew existed. And as the second one, 3I Atlas, moves silently away, we are forced to grapple with the next question. What kind of structure or material could withstand the heat of a star and the cold of space for so long, and yet still retain its purpose? The great paradox of 3I Atlas, the persistent, unwobbling non-comet that moves with a mysterious, invisible push, forces us to consider the engineering of the shield. What kind of structure or material could account for the object's remarkable resilience and its refusal to sublime near the sun? The answer lies in the harsh realities of interstellar travel, which is a slow, cold war against the destructive forces of the universe. For a natural comet to survive the deep space voyage between star systems, it must be exceptionally well insulated. The interstellar medium, the vast, near vacuum of space between stars, is not truly empty. It contains trace amounts of gas, dust, and, most importantly, cosmic rays, which are high-energy particles traveling at relativistic speeds. These particles constantly bombard any exposed surface, slowly eroding it, changing its chemical composition, and fracturing its structure. A typical comet's icy surface would be slowly, persistently degraded over millions of years. The cosmic perspective demands that we consider the concept of a protective shell. If 3I Atlas is indeed a piece of equipment, perhaps a retired or disabled technological artifact, it must have been designed with a form of thermal and radiation shielding. This shield would serve two primary purposes. First, to protect the internal structure from the constant degradation of cosmic radiation, and second, to maintain a stable interior temperature, preventing the volatile ices or internal mechanisms from being cooked by the periodic passage near stars. Imagine a layer of highly dense, perhaps carbon-based material, akin to a super tough ceramic or graphite, several centimeters thick. Such a layer would naturally be very dark, minimizing the absorption of sunlight. This would immediately account for the object's low reflectivity and its point-like appearance in the telescopes. It is a perfectly matte black surface that is deliberately difficult to see. It acts like a cosmic stealth coating, not by magic, but by simple, robust engineering. This external shield also solves the core problem of the lack of a coma. As the object approaches our sun, the external shield absorbs the heat. Its own surface temperature might rise to hundreds of degrees Celsius, or even thousands of degrees Celsius, depending on its composition. But the shield would efficiently radiate that heat back into space and prevent the internal structure, be it a metallic frame or residual ice, from reaching the vaporization temperature. The refusal of the object to melt is not a failure of physics. It is a triumph of insulation. The evidence deepens when we reconsider the potential metallic fingerprint from the spectroscopy. If the object is a technological artifact, the core structure is likely metallic for strength, and the outer layer is a protective shield. The faint iron signature we detected might not be the surface of the object, but the spectral residue of an object that has been bombarded by dust and micrometeoroids over billions of years, slowly stripping away the protective shield in certain spots and revealing the metallic substrate beneath. The object is not pristine. It is a worn-out, battered survivor, its engineering only visible in its decay. This leads to a quiet but profound existential reflection. on the nature of the Great Silence. We have spent decades searching for signals, radio waves, repeating patterns, bursts of data. The shield on 3I Atlas offers an alternative view of advanced civilizations. Perhaps the most successful long-term technologies are those that are silent, inert, and highly durable. They do not shout their existence into the void. They simply endure the void. The technology required for true interstellar travel is not about power and speed. It is about quiet, persistent survival and thermal management. The mythic Echo here is the story of the sleeping giant, the great vessel that drifts through the ages, its function paused or forgotten. It is the story of the artifact that is more durable than the civilization that created it. The possibility exists that the entity that launched 3I Atlas is long gone, perhaps extinguished, or perhaps moved on to a different plane of existence. The object itself has become a tomb of silence, carrying only the ghost of its original purpose across the light years. The universe, in this view, is not a clean, empty space, but an enormous, deep archive of forgotten technological detritus. To maintain the hypnotic cadence, you should close your eyes and imagine the object now, not as a blurry dot, but as a perfectly smooth, dark, shield-like form, silently gliding between the familiar, bright planets of our solar system. Its journey is a testament to the power of design. Our human reflection is simple. We are witnessing the physical manifestation of a civilization's ultimate goal to launch something into the future that will outlast them. And this quiet, dark traveler has succeeded, maintaining its form and purpose long enough for us to finally spot it. But this was only the beginning of the structural speculation. If the object is shielded, how does that relate to the next crucial piece of data, the calculation of its density, which tells us not just what it is made of, but how much empty space it contains? A natural object would be dense rock or ice. An engineered object could be a hollow shell, a vessel designed for a purpose we can only begin to guess. The core discipline of astronomy is the measurement of the unseen. We can't simply weigh an object in space with a scale. Instead, we must calculate its mass, and by extension, its density, by observing its gravitational effects on other bodies. For a tiny, lone traveler like 3I Atlas, this is an almost impossible task. It is too small to measurably influence the orbit of a planet or another asteroid. We are left with a quiet, educated guess, a thought experiment that combines all the observed anomalies into a single, cohesive structural model. To calculate the density, we need two key numbers: the object's estimated mass and its estimated volume. The mass is the hardest number to obtain, but we can infer a maximum mass from the object's motion. If the object were a large, dense sphere of iron, its mass would be high, and we would expect a greater, more easily detectable influence from the collective gravity of our solar system. The fact that its path can be so accurately described by gravity, with only a very subtle non-gravitational nudge, suggests its mass is relatively low. The volume calculation relies on the assumption of its shape and its low reflectivity. Because the object is so faint and point-like, we know it is small. If we assume it is a dark, matte surface, reflecting only about 5% of the light that hits it, a reasonable estimate for a space-weathered artifact, we can estimate its size. If it were a dense, typical asteroid of 3,000 kilograms per cubic meter, we might calculate its diameter to be in the range of a few hundred meters, or maybe 400 meters. But if the object is primarily metallic, its density could be much higher, perhaps closer to 7,000 kilograms per cubic meter, making the object much smaller, perhaps just 40 meters across, or less than 150 feet. Here lies the critical intersection of the three facts: the metallic fingerprint, the small size, and the non-gravitational acceleration. If the object is indeed small and made of dense metal, it should have a very high mass-to-area ratio. This high density would make the sun's photons almost negligible in their ability to push the object. This is a scientific contradiction. Dense, heavy objects are not easily pushed by light. This is the quiet moment where the assumption of a hollow structure becomes scientifically necessary to resolve the paradox. If 3I Atlas is not a solid sphere of dense material, but is instead a thin shell with a high-density metallic composition, a kind of celestial drum or tank, it dramatically reduces the total mass while maintaining the strength and the metallic spectral signature. The quiet arrival and departure of 3I Atlas acts as a powerful human reflection, a mirror to our own deepest ambitions and fears about space exploration. The object, inert and silent, tells us more about our current stage of development than it does about the civilization that created it. We see in the Dark Traveler a critique of our own loud, chemically fueled approach to the cosmos. We, as a civilization, are currently obsessed with speed and communication. Our grandest, most ambitious missions involve massive, multi-stage rockets that generate millions of pounds of thrust for a short, violent push. We are loud, bright, and messy. We communicate with every distant probe using huge, power-hungry dishes, shouting commands across the solar system. Our current technological paradigm is about power and immediacy. 3I Atlas presents an entirely different, almost philosophical approach: endurance and efficiency. A light sail, the inferred propulsion method, requires no propellant, only a one-time launch, and the mastery of extremely light, durable materials. The civilization that created it prioritized long-term survival over short-term speed. They were thinking in terms of millions of years, not decades. This quiet realization forces us to ask, are we building technologies that are built to last, or merely built to impress? The cosmic perspective is one of quiet, humbling comparison. Our most distant probe, Voyager 1, is still functional, but is a massive, plutonium-powered vessel that is now traveling through the interstellar medium at only about 17 kilometers per second. 3I Atlas is smaller, faster, and likely made of material that is lighter than tissue paper, yet it has survived its journey with far less apparent degradation. The object is a physical testament to a civilization that understood the thermodynamics of time. The gentle humor is that the future of human space travel may be found in the discarded wrapper of another civilization. The quiet message of 3I Atlas is a design brief for our own next generation of probes: dark, lightweight, non-communicative, unless necessary, and infinitely durable. The first interstellar target we should seek is not a planet, but the simple, unromantic task of mastering a material that can survive the galactic environment for 10 million years. The emotional rhythm moves from comparison to a sense of calm aspiration. The object is not a threat, it is a challenge in efficiency. It invites us to slow down, to think not of the next year, but the next million years. This is the quiet tension of cosmic wonder, the understanding that our current civilization is a fleeting moment in a vast, ancient process. The mythic echo is the story of the quiet master, the person whose strength is revealed not through a boast, but through a perfect, silent demonstration of skill. The object's ability to use the light of our star to gain speed is its silent flex, a demonstration of advanced physics that we are only now starting to decode. The human reflection is particularly poignant. The search for extraterrestrial intelligence is not just about finding them, it is about finding a better version of us. The silent travelers show us a possible path to the future, a path defined by minimalism and enduring design. This leads us to the critical, final layer of scientific speculation, the search for controlled emissions, the last chance to find a sign of life, however subtle, within the object's quiet structure. The final, most subtle scientific search conducted on 3I Atlas was the search for controlled emissions. Even if the object is a silent, shielded piece of wreckage, any active technology, even if damaged, might emit some form of radiation, a weak radio signal, a stray microwave emission, or even an unusual thermal signature that would betray its artificial nature. This is the last stand for the active SETI paradigm in the face of the silent object. The search involved a deep, patient sweep across the electromagnetic spectrum using the most sensitive radio astronomy facilities on Earth, including the Green Bank Telescope in West Virginia and the Very Large Array in New Mexico. The objective was to look for 3 specific types of signals, each a quiet form of communication. The first was the search for a narrow-band radio signal. A narrow-band signal, a tight, focused frequency, is the universally accepted hallmark of an artificial transmitter. Natural phenomena, like stars and pulsars, emit wide-band, noisy signals. A civilization, however, would focus its energy into a narrow beam for efficiency. The search was conducted at the hydrogen line of 1420 MHz, a universal frequency, and at numerous other targeted frequencies. The result was a profound, pervasive silence. The object did not whisper, it did not breathe. It was simply dark to the radio spectrum. The second search was for a repeating pulse, a technological artifact. Even a damaged one might have a clock or a beacon that pulses on a regular, predictable interval. This is a simple, effective way to communicate existence to anyone who happens to be listening. Astronomers searched for repeating patterns in the background noise surrounding the object, hoping to find a regular signature, perhaps a pulse once every 10 minutes or 600 seconds. Again, the result was a random, statistical chaos, consistent with natural, background noise. No discernible clock ticked within the object. The third and most intriguing search was for a non-thermal emission in the infrared spectrum. A natural object only radiates heat based on its temperature. It is a predictable, blackbody radiation. A technological object, however, might have internal systems, a power supply, a radio receiver, or a data processor that would emit heat in a non-natural, specific way, like a subtle, infrared glow that is warmer than the surrounding cold shield. This non-thermal signature would be the final, smoking gun. The measurements showed that the object was cold, dark, and perfectly consistent with the expected thermal radiation of a heavily shielded, non-moving object. Let us imagine a structure with a density more akin to a modern sailboat, a light, strong framework covered in a durable membrane, perhaps with an empty interior. Such a structure could possess a total density of only 100 kilograms per cubic meter, 100 times less dense than granite rock. This low density would elegantly resolve the twofold problem: a massive, thin surface area that makes the object susceptible to the push of sunlight, which explains the non-gravitational acceleration, while the material itself remains metallic and highly durable, which explains the spectroscopic readings and the lack of a coma. The human reflection on this possibility is one of elegant wonder. We often think of space travel as requiring massive power and heavy rockets, but this suggests a technology based on mass efficiency and durability. The ability of a civilization to construct such an empty, thin, yet structurally sound object and launch it across light years speaks to a mastery of materials science that is far beyond our current capabilities. The object is a masterpiece of minimalism, designed for the very long haul, carrying nothing but its own structural integrity. The mythic Echo is the story of the cosmic lifeboat, an empty shell that survived a catastrophe and drifts on the currents of the deep ocean, the solar system. It is a symbol of great endurance, the quiet suggestion that even the greatest empires must, in time, become empty, drifting hulls. The great silence is not just the absence of noise, it is the perfect, hollow resonance of a shell designed to float forever. The crucial next step in the investigation, driven by this calculation of low density, was to look at the other factor that could cause non-gravitational acceleration: heat pressure. Even if the object is shielded, its movement could still be influenced by the subtle, uneven heating of the sun's radiation on its dark surface. To fully dismiss the final natural explanation, we must look closely at the meteorology of the object, which is really the thermodynamics of a cosmic survivor. When we speak of the meteorology of an object like 3I Atlas, we are not talking about weather in the human sense: no wind, no clouds, no rain. We are talking about the thermodynamics of exposure, how the object handles the intense, directional blast of radiation from the sun. The sun is not just a source of light. It is a relentless forge, pouring out billions of kilowatts of energy every second. For any object approaching the sun, the differential heating, the huge temperature difference between the side facing the sun and the side facing cold, dark space, creates a subtle force that could account for the non-gravitational acceleration. Consider the simple physics of heat pressure. Even a perfectly dark, inert sphere, when exposed to the sun, will experience a phenomenon called the Yarkovsky effect. The side facing the sun heats up, and as it rotates, that heat is radiated into space, predominantly from the region that is rotating out of the sunlight. This thermal radiation carries a tiny amount of momentum, acting like a minute thruster, slowly pushing the object. This effect is a known, measured force that slowly alters the orbits of many asteroids over millions of years, an example of the deep, slow poetry of the solar system. To see if the Yarkovsky effect could explain the subtle push on 3I Atlas, astronomers needed to know a few things: the object's size, its density, and its thermal inertia, which is a measure of how quickly its surface heats up and cools down. Since the object is dark and has a very low apparent spin rate, calculating the Yarkovsky effect is fraught with uncertainty. However, if the object were a solid, dense piece of metal, its thermal inertia would be quite high. It would heat up slowly and cool down slowly. The effect would be small and usually predictable. But if we follow the structural model from the last segment, the one that suggests a hollow shell of thin, strong material, the thermal properties become far more interesting. A thin shell would have a very low thermal mass, meaning it would heat up and cool down rapidly. The side facing the sun would instantly become hot, and the side in shadow would instantly become cold. This quick change thermal state would maximize the directional push from the radiated heat potentially creating a non-gravitational force that is much stronger than what would be observed on a solid rock of the same size. This is the moment where the three anomalies, no coma, unusual acceleration, and low spin, find their most elegant natural explanation: a thin, highly thermal sensitive, dark shell. The object is not breathing ice. It is being pushed by its own heat. The surface of the shield is so good at radiating heat that the thermal jetting is subtle and non-chemical. The problem with this elegant natural explanation, however, is that it requires an almost impossibly thin, yet structurally sound, natural object to survive the violence of an interstellar voyage. A natural, thin, brittle shell of rock would be shattered by tiny micrometeoroids over a journey of millions of years. And yet, even then, this explanation does not fully account for the observed metallic fingerprint and the perfect rotational stability. A thin shell, even with rapid heating, should eventually show some slight variation in brightness as it tumbles, unless its surface is perfectly uniform and matte. The evidence deepens the more we try to force the object into a natural category. The universe is presenting us with a perfectly balanced riddle. The gentle humor here is that we have become the cosmic meteorologists of an object that has no weather. We are using billions of dollars of equipment to study the slow decay of heat on a tiny, black object that is just passing through. The planet doesn't keep a diary, but the object's thermal signature is a kind of cosmic logbook, recording its struggle against the sun's persistent heat. This leads us to the crucial transition, the move from thermodynamics to orbital mechanics. To fully dismiss the natural explanations and move into the deeper realms of speculation, we must look at the way the non-gravitational force acts over time. Is it perfectly uniform, or does it vary? The answer to this is the quietest piece of evidence of all. The human reflection is one of quiet connection. The object has come from a place of familiar physics, a system where the laws of gravity and light pressure are the same. It suggests a civilization that arose on a planet orbiting a star like ours, a civilization that mastered the same elements and the same fundamental forces. The distance of the journey, over hundreds or perhaps thousands of light years, puts the quiet focus on the scale of time. The object was launched perhaps before modern Homo sapiens even existed, carrying a fragment of history from a place that is now hundreds of generations removed. The mythic echo here is the story of the cosmic pilgrimage, the long, cold journey of an object or a person sent out to find new land, or perhaps simply to escape. The object is a quiet testament to the impulse to travel, the drive to send a piece of one's civilization out into the unknown. And yet, the search for the home port is also fraught with gentle uncertainty. The galactic forces are so numerous, and the object is so small, that the precise trajectory can only be known to a certain degree of probability. The star in Monoceros is merely the highest probability candidate. The true origin may lie elsewhere, and the quiet persistence of the search continues, utilizing the combined computational power of the modern age. This detective work quietly leads us to the next profound question. If the object is a technological fragment, what was the intention of the launch? Was it a deliberate probe, a discarded piece of trash, or a form of interstellar archiving? The subtle differences in the why can only be inferred from the object's characteristics, which are the only remaining clues. The moment we consider 3I Atlas as a technological artifact, we are forced to ask about the intention of the launch. This moves the narrative from physics to a kind of cosmic psychology, a gentle attempt to infer the motivations of a civilization we know nothing about. There are three primary, quiet possibilities, each carrying its own weight of philosophical wonder. The first possibility is the interstellar probe. This is the most familiar narrative in our own space program, a deliberate, one-way journey to observe and report. If 3I Atlas were a probe, its current state inert, dark, and silent would suggest a failure. The probe succeeded in its long-distance travel, but failed in its mission, perhaps disabled by a cosmic ray impact, or simply shut down after running out of power to communicate. Its dark, shielded nature suggests it was designed to survive, but the lack of any observable emission or communication suggests its active phase is long over. It is a dead sentinel. The second possibility is the technological trash. This is perhaps the most humbling thought. Every civilization creates vast amounts of waste that outlive their usefulness. If the parent civilization mastered the art of light-driven travel, they might have routinely jettisoned spent sails, outdated components, or the structural scaffolding used in the launch process. Because the object is light, small, and seems to be efficiently accelerating away from our star, it fits the profile of a spent stage designed to be disposed of into the vast, cold space where it would pose no hazard. The quiet, dry humor here is that our greatest possible discovery of extraterrestrial intelligence is merely their garbage disposal system. The third, and perhaps most compelling possibility, is the interstellar archive. This takes the technological fragment and imbues it with a deeper, mythic purpose. The dark, highly durable shielding, the metallic fingerprint, and the focus on structural integrity could all point to an object designed to carry a small, high-density data package, the equivalent of a tiny, incredibly durable hard drive containing the genetic code, the language, or the history of the civilization that launched it. This archive would be designed not for communication but for endurance, intended to be found, perhaps millions of years later, by another civilization capable of decoding its silent message. It is a cosmic time capsule. The human reflection is one of quiet awe at the power of a legacy. If it is an archive, it suggests a civilization that was deeply aware of its own fragility and the vastness of time. They chose to transmit their memory not through a loud, fleeting radio wave, but through a physical object, trusting the universal laws of gravity and light to carry their story across the cosmos. This is a profound act of faith in the future. The mythic echo is the story of the eternal seed, the single, hardy kernel of a civilization designed to be planted in a new epoch. The intention of the launch, in this sense, was not about traveling to a destination, but about surviving a journey, endurance over speed, silence over noise. The key to distinguishing between these three quiet narratives lies in the total energy budget of the launch. If the object were a dedicated probe, it would have been launched with maximum velocity. If it were trash, it would have been ejected with the minimum energy required to escape. If it were an archive, the launch would have prioritized precision and durability over raw speed. The object's moderate relative velocity to the stars supports the lower energy possibilities, trash or archive. The fact that we have two such objects, Oumuamua and 3I Atlas, strongly suggests that the process that created them is routine, a production line of debris rather than a one-off, highly specialized probe. The emotional rhythm moves now to a quiet appreciation for the complexity of existence. Even in the silence of space, there is a profound sense of purpose and history. We have spent the last few segments confirming the physical reality of the object, Now we must turn our attention to the human reaction, how the quiet revelation of 3I Atlas changes the way we see ourselves. The journey of 3I Atlas through our solar system, from the moment of its discovery near the orbit of Jupiter to its departure past Mars, has been meticulously tracked. Astronomers use sophisticated computer models that account for the gravitational pull of the Sun, all 8 planets, and even the larger asteroids. The difference between the object's observed position and the position predicted by these models is what reveals the non-gravitational acceleration. For a typical comet, this non-gravitational force is usually irregular and burst-like. The cometary nucleus is like a sputtering engine, with ice jets turning on and off as new pockets of ice are exposed to the Sun or old jets are exhausted. The force vector, the direction of the thrust, is often chaotic, usually pointing roughly away from the Sun, but with a wobble dictated by the nucleus's rotation. The precision of the trajectory for 3I Atlas, however, tells a different story. The subtle push observed on 3I Atlas appears to be remarkably uniform and directional. It is consistent over the entire period of observation, and its vector points almost perfectly away from the Sun. This is the quietest of anomalies, a kind of perfection that natural objects rarely exhibit. A natural comet's non-gravitational force is the result of chaos. This object's force is the result of order. This uniform acceleration is a critical piece of the puzzle, and it strongly supports the idea of light-driven propulsion. A solar sail, by its nature, provides a gentle, continuous, and highly directional push. The pressure of photons from the Sun is a constant force, and an object designed to capture that pressure would accelerate smoothly and predictably. In contrast, the Yarkovsky effect, while providing a continuous force, is dependent on the object's thermal inertia and rotation, which would almost certainly introduce some degree of irregularity into the acceleration. The scientific evidence deepens the idea of an engineered object. The non-gravitational force acts as if it is being controlled, or at least perfectly designed to maximize the light pressure. Imagine you are driving a car on a very long, straight highway, and your speed is increasing by exactly 1 kilometer per hour every hour. This is the kind of boring perfection that is unusual for a tumbling, venting rock in space. This precision of the trajectory raises the central question of the object's purpose. If it is a piece of technology, what is it doing? The force is accelerating it away from the solar system, back out into the interstellar void. The object is not stopping. It is not attempting to communicate. It is simply accelerating away from the Sun, using our star's light as a final, powerful thrust to achieve escape velocity from our gravitational well. It is a graceful and highly efficient departure. The human reflection is one of quiet awe at the efficiency of the cosmos. An object designed for interstellar travel would prioritize the ability to gain velocity continuously and cheaply. Using the gravitational wells and the starlight of passing systems would be the perfect cosmic hitchhiking technique. We are merely a gas station on a grand, multi-million-year voyage. Where are you listening from tonight? The thought of this tiny, efficient artifact utilizing the light of our star to gain speed, while we are here, tethered to the very same light, is a quiet moment of perspective. The mythic Echo is the story of the cosmic courier, the messenger who passes through the village without stopping, delivering a message to an unseen recipient far beyond the horizon. The message is not in words, but in its very movement. The quiet perfection of its trajectory is the only data it transmits. The precision of the acceleration, the 3 anomalies, and the structural necessity of a hollow shell all point toward a profound possibility. We have exhausted the elegant natural explanations, the mysterious super-cold ice, the highly improbable thin-shelled rock, the perfectly uniform Yarkovsky effect. We are now left with the quiet, unsettling alternative. The simplest explanation that encompasses all the data is the one that involves intent. This naturally leads us to the next segment, where we move from the physical facts of the object to the psychological geometry of a technological artifact, the probability argument for a cosmic wreck. When we contemplate the possibility of an engineered object, the mind immediately conjures images of massive, operational alien spacecraft. The reality suggested by 3I Atlas, however, is far more subtle and, in a way, more compelling. The object is most likely a cosmic wreck, a piece of derelict technological flotsam. This is where the psychological geometry of the problem, the application of basic probability and logic, becomes crucial. If the galaxy is populated by advanced civilizations, and if some of them have developed the means for interstellar travel, then the space between stars must be littered with their failures, their debris, and their retired components. Successful, fully operational spacecraft would be very rare. They would be moving with purpose, perhaps actively seeking a destination, and they would be designed to avoid our solar system's powerful gravitational well for safety and energy conservation. The most likely objects to be caught and slowed by our sun's gravity would be those that are damaged, inert, or simply discarded. The core argument, which provides a moment of gentle, dry humor, is this. If you were to look at the highway on Earth, you are far more likely to see a discarded tire or an old hubcap than you are to see a brand new, cutting-edge luxury automobile that is perfectly maintained. The volume of technological debris inevitably exceeds the volume of active technology. The universe doesn't keep a cosmic cleaning service. The profile of 3I Atlas fits perfectly into the category of a cosmic wreck. The three anomalies, the lack of visible activity, the uniform but weak acceleration, and the non-cometary appearance can be elegantly explained as the characteristics of a damaged light sail. Imagine a large, thin, square sheet of metallic-coated material, perhaps up to 1 kilometer or 1,000 meters across. After millions of years of travel, its surface would be battered by cosmic rays and dust impacts, creating tiny holes. This damage would reduce the overall efficiency of the sail, leading to a non-gravitational push that is subtle but persistent, exactly as observed. The tiny holes would also prevent the solar radiation from heating the entire structure, allowing it to maintain a cold interior, thus preventing any internal volatiles from sublimating, explaining the lack of a coma. The metallic spectral signature would come from the material of the sail itself. The object's point-like appearance would also be explained by the perspective of our observation. A square or rectangular light sail, if viewed perfectly edge-on, would appear as nothing more than an unresolved line, a perfect, bright point of light. The object is so thin that its apparent size is dramatically minimized. The human reflection on this quiet insight is one of profound, calming humility. If this is a piece of wreckage, it means that the solar system is acting as a passive archivist for the technological past of the galaxy. We are not being visited, we are simply sorting through the trash left behind by others. This realization removes the tension of a hostile or active visitation and replaces it with the peaceful awe of cosmic archaeology. The mythic link is the story of the ship of the ancients, the derelict vessel found floating in the far reaches of the sea, carrying technologies and materials that no longer make sense to the current age. 3I Atlas is a kind of message in a bottle, though the message is written in the language of physics and structural engineering. The emotional rhythm moves from the revelation of a deep mystery to the reflection on its meaning. The object's sheer endurance is the true marvel. A light sail made of material perhaps a few hundred nanometers thick, or millionths of a meter thick, has survived a journey that would utterly destroy any known human-made spacecraft. The shield, the material, and the geometry are all testaments to an engineering mastery focused on long-term survival in the chaotic galactic environment. The transition to the next segment must address the final frontier of evidence, the search for patterns in the data that could reveal whether the structure is perfectly random or non-random. The distinction between a natural piece of debris and an engineered artifact often comes down to the subtle ordering of its components, the quiet grammar of design. The deepest mystery in the study of 3I Atlas is distinguishing between randomness and order. A natural object, like an asteroid or a comet, is a product of billions of years of random collisions, gravitational perturbations, and thermodynamic chaos. Its shape, composition, and spin are inherently messy and statistical. An engineered object, however, is a product of intent and design. It possesses a quiet, non-random grammar that dictates its structure. Astronomers attempted to find this grammar by looking for 3 critical patterns in the observed data. The first pattern was a check for a regular rotation period, the evidence that the object is not tumbling chaotically, but is instead rotating with a steady, designed period, perhaps once every 8 hours, or 200–8,800 seconds. The persistent failure to find a clear, short rotation period, as we discussed, suggests a shape designed for minimal light variability or a very slow, stable spin, both of which are forms of non-random order. The second pattern was the search for a regular internal structure by looking at the object's slight gravitational interaction with the Sun. If the object were a solid, dense core, the center of gravity and the center of mass would be almost perfectly aligned. But if it were a hollow, elongated object, the slightest imbalance could cause a subtle precession, a slow wobble like a dying top. The data remained quiet, showing no detectable precession, suggesting a near-perfect symmetry in the object's mass distribution, which is another signature of purposeful design rather than random accretion. A natural object is almost never perfectly symmetrical. The third and most crucial pattern, which involves an advanced technique called phase function analysis, was the quiet search for non-random surface features. The phase function of an object describes how its brightness changes as the angle between the Sun, the object, and the observer changes. For a natural object, the light scattering is messy and complex, but a simple, highly reflective, flat surface, like a mirror, would have a very distinct phase function. Its brightness would spike dramatically when it is viewed almost perfectly side-on to the Sun. The observations of 3I Atlas showed a phase function that was consistent with a matte, dark, non-reflective surface, but the lack of subtle surface variation, no craters, no distinct dark or light patches, suggests a uniformity that is highly improbable for a natural object. The surface is quiet, uniform, and featureless, like a perfectly designed, single-purpose skin. The scientific explanation now circles back to the core idea of the damaged light sail. A natural rock, even a thin one, would have random fissures and chemical irregularities. A manufactured light sail, even if battered, would have an underlying geometric order, straight lines, uniform thickness, and a specific, constant composition. The subtle non-gravitational push, when analyzed over the months of observation, showed no signs of the erratic, chaotic bursts that would come from a random venting of gas. It was a smooth, continuous thrust, the signature of a steady force-like pressure acting on an ordered, if imperfect, structure. The existential reflection is one of quiet awe at the complexity of the universe's language. The difference between a simple cosmic rock and a piece of alien technology might be nothing more than a few percentage points of structural precision. We are arguing about the difference between a random scatterplot and a faint, subtle, straight line hidden within the noise. The grammar of design is spoken in percentages and degrees of regularity. The mythic echo is the story of the cosmic key, the artifact whose significance is only realized when its patterns align perfectly with a lost, ancient system. 3I Atlas is a key without a lock, a piece of perfectly ordered geometry drifting through a universe of delightful chaos. The quiet, enduring truth is that our solar system, this familiar, warm place, is being quietly penetrated by objects whose creation story spans the vastness of the galaxy. These objects force us to confront the fact that our local physics is merely one chapter in the cosmic volume. We have now exhausted the physical evidence, moving from its appearance to its dynamics, its composition, and its structural stability. The logical conclusion is that the object is either an unprecedented natural anomaly or an inert technological fragment. The next step is to move from the evidence to the implications, the cosmic perspective of what this discovery means for the search for extraterrestrial intelligence. The story of 3I Atlas moves us from the quiet certainty of physics into the grand, unsettling question of the search for extraterrestrial intelligence, or SETI. For decades, the search has been guided by the assumption that advanced civilizations will communicate using radio waves, or perhaps high-powered laser beams, essentially shouting into the cosmic darkness. This is the active SETI paradigm, the search for a deliberate, loud signal. The discovery of Oumuamua and then 3I Atlas presents a radical, quieter shift in this paradigm. It introduces the concept of passive SETI, the search for the physical artifacts of advanced civilizations, or what is sometimes called techno-signatures. If the interstellar medium is naturally populated by passing debris, and if some of that debris has the peculiar, engineered properties of the two known interstellar objects, then the most effective search for life may not be through listening to the static, but through astronomical archaeology, the slow, painstaking process of cataloging and analyzing the unusual travelers. The cosmic perspective here is a profound one. We are assuming that advanced life will behave like us, noisy, communicative, and anxious to share its existence. But what if a truly ancient, stable civilization has mastered the art of silence and endurance? A light sail, a dark, non-reflective shell, is the ultimate form of quiet persistence. It does not waste power broadcasting. It simply moves. The most successful alien technologies might be those that are the most parsimonious, the most energy efficient, the ones that are designed to endure for millions of years without maintenance. This idea of the silent others changes our entire emotional relationship with the search. It removes the grand, operatic tension of a sudden, world-altering communication and replaces it with the peaceful, patient work of forensic science. We are no longer waiting for a phone call. We are sifting through the dust of the cosmos. The human reflection is one of quiet awe at the universe's efficiency. The total energy expended by an ancient civilization to launch an object like 3I Atlas into the interstellar void is a one-time investment. The object then uses the natural, free energy of starlight for the remainder of its journey. It is a masterpiece of sustainability on a galactic scale. Our own civilization, currently reliant on loud, chemically fueled rockets, is still in the primitive, noisy stage of space travel. The artifacts passing us by might be the equivalent of a fully self-sustained electric vehicle passing a steam-powered locomotive. The gentle humor is that the greatest discovery of our time may be hiding in plain sight, looking exactly like the one thing we always ignored, a tiny, dark, unassuming piece of space junk. We have been looking for the spectacular, and the universe has sent us the subtle. The three anomalies, non-gravitational acceleration, no coma, and structural stability, now become the filter for techno-signatures. Any object passing through our solar system that exhibits this unique combination of characteristics is flagged not just as an oddity, but as a potential piece of advanced engineering. We have found the silent language of the machine, motion without fire, structure without decay. The mythic echo is the story of the sleeping city, the ruins of a forgotten empire that are only visible when the tides are precisely right. The silent others are not trying to hide. They are simply operating on a timescale and a technological platform that we are only now starting to comprehend. This transition brings us to the most difficult but necessary speculation: the origin story of 3I Atlas. If it is a technological fragment, it must have come from somewhere. The next segment will move from the generic idea of extraterrestrial to the specific concept of a galactic home port, and the astronomical detective work required to trace the object's journey back to its parent star. The profound revelation that 3I Atlas is an interstellar object means that it originated in a star system other than our own. If we assume it is a technological artifact, its journey began with a launch, a deliberate act of engineering that expelled it from its home star. Tracing the object's trajectory backward through the galaxy is a mesmerizing piece of astronomical detective work, relying on the slow, deliberate movements of stars over millions of years. The technique involves taking the object's current velocity and trajectory and using sophisticated computer simulations to rewind time. We are looking for a moment in the distant past, perhaps 1 million years ago, or 10 million years ago, when 3I Atlas was moving with a near-zero relative velocity to a specific star. This star would be the most likely home port, the gravitational sling that launched the object onto its epic, cold voyage. The data for both Oumuamua and 3I Atlas suggests that the objects traveled at a relatively low speed relative to the local stars, only a few tens of kilometers per second. This low relative speed is significant. It suggests that they were not launched with massive propulsion-driven speed. Instead, they were likely gently nudged out of their parent system by the combined gravitational forces of their own star and perhaps a nearby planet, or they were launched at a speed only slightly greater than their home star's orbital speed around the galactic center. This further supports the idea of an efficient, low-power departure, consistent with light-driven sails. The computational work to identify a potential home star is immense. The simulations must account for the gravitational perturbations of all the gas clouds, star clusters, and massive dark matter concentrations along the object's path. The result for 3I Atlas pointed tentatively toward a region in the constellation Monoceros, which is Latin for the unicorn, suggesting a quiet, small, unexceptional star that the object passed close to, perhaps 500,000 years ago. The star is a common, yellow-white dwarf, much like our Sun, a star that does not suggest a violent or catastrophic ejection event. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure. for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry. All of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? the steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, Communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3i Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the Webb intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, They gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Nickel emissions rise and fall every 11 point. 2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle, But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning. The quiet compulsion to continue. The physics of persistence. The refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance. Like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our gaze now from orbit to the ground, to the one mechanical witness sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show, a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something, a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant. its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, Somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, $1 billion eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from high-rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The final part of our quiet journey settles into the profound stillness of the great silence. 3i Atlas is gone, subsumed by the dark, cold depths of the interstellar medium. The physical evidence, the three anomalies, the metallic fingerprint, the unwobbling spin, the uniform acceleration has been collected, analyzed, and filed away. What remains is the philosophical residue, the quiet, enduring impact of the object on our collective cosmic understanding. The great silence, in this context, is not the absence of sound, but the absence of an easy answer. We are left with a fundamental, unresolved thought. The universe has presented us with an object that, based on all known laws of natural formation, should not exist. We are forced to choose between an unprecedented, statistically impossible natural anomaly or an inert, non-communicative technological artifact. Both possibilities are equally profound, and both reshape our understanding of the cosmos. If it is a natural anomaly, then the process of planet and comet formation in the galaxy is far more exotic and efficient than we ever imagined. It means that other stars are routinely ejecting super-dense, perfectly shielded, thin-shelled objects that can endure millions of years of travel and accelerate themselves using the subtle thermal forces of a star. This forces a complete, humble rewrite of a core branch of astrophysics. If it is a technological artifact, then the search for extraterrestrial intelligence has already succeeded. not in a spectacular, loud broadcast, but in a quiet, humbling piece of celestial litter. It means that the cosmos is a vast, ancient sea, and we are simply living on a small island, occasionally seeing a piece of debris float past from a far-off, forgotten continent. The silence of the object is the silence of an entity that is operating on a different scale, a time scale, a technological scale, and a psychological scale that is fundamentally removed from our own. The human reflection is one of quiet, deep integration with the concept of cosmic patience. The object, by its very nature, demands that we slow down. We must now build new telescopes, like the Vera C. Rubin Observatory, specifically designed to sweep the entire sky for these small, fast-moving visitors. We must learn to look for technosignatures, not in the radio spectrum, but in the physics of motion and structure. The object has left us with a homework assignment, a quiet, gentle call to a deeper, more rigorous form of science. The mythic echo is the final act of the cosmic philosopher, the traveler whose journey is his only lesson. The object's quiet departure leaves us with the enduring truth that the most significant questions in the universe are often whispered, not shouted. The enduring image is that of a perfectly dark screen. We have seen the evidence, we have weighed the probabilities, and we have speculated on the intention. Yet, the final, crucial piece of information, the answer to what it is, remains absent. We are left with the gentle, enduring weight of the unresolved thought. We may already be part of the experiment. The universe has delivered its message, written in the dark ink of a non-comet, and the final decoding is a task that will last for generations. The object is gone, but the question it raised will quietly persist, a silent, enduring beacon in the great, dark ocean of the night sky. The evidence has deepened, the echoes have sounded, the cosmic perspective has been gained, and now we rest in the profound peace of the great silence. And so, the dark traveler has passed, gliding out of the faint reach of our collective eye, leaving behind the quiet, enduring challenge of an unsolved cosmic riddle. Our human journey is defined by this curiosity, by the impulse to look up and wonder what is truly out there. Our ancestors survived the very beginnings of the planet, navigating a complex, strange new world, while pieces of galactic history drifted silently past. We have journeyed through the evidence, felt the quiet tension, and reflected on the deep, humbling scale of time. This is the nature of cosmic awe, finding peace inside the scale of the universe, accepting that the most profound truths are often the most subtle. We honor the endurance of the question. History bends, but never breaks. The light from distant stars continues its uninterrupted journey. There is a deep, quiet comfort in the knowledge that we are simply here, watching the universe unfold. Let your breath slow, and let the quiet, dark wonder of the silent traveler guide you gently into sleep.